Hello, everybody. How are you guys today? I'm sorry that I will not be with you all in class today. My 5-year-old has like the flu, so I have to stay home with him. I do hope that y'all have a good weekend, and I can't wait to see you all on Monday. Remember, you have IXL due today, you have a Delta Math due today, and then today I'm going to make these notes for you. Please take the notes in your notebook, and there's going to be another Delta Math that I'm assigning for these practice problems, which will be due on Monday. Okay. Today we're going to be looking at how to solve square root equations. So we've already learned how to graph square root functions. We use the transformation rules and the shifts left and right, up and down, and using the a value to figure out our points and where to graph. Today what we're going to do is what we're going to solve equations with square roots. So let's take a look at this first example. Y equals x plus 5. We've already kind of seen these during the week. We learned how to graph them. But now, what if instead of being equal to y, what if this was equal to a number? Square root of x plus 5 equals, instead of y, let's make it an easy number. What if it was equal to 0? Now I've got an equation that I can solve because I've got numbers in it instead of two variables. I only have to solve. I can solve this for x. And the way I can do that is, like we've done before, I'm going to isolate the variable and what's on the square root, what's in the radical. I'm going to isolate it by getting it on one side of the equal sign. And I'm going to take everything else that's a number, and I'm going to move it to the other side of the equal sign. Okay, so how do I do that? Well, let's take a refresher here. I can move this 5 to the other side by subtracting 5 from both sides. These 5s will cancel out, and I'll bring down my square root of x, bring down my equal sign, and 0 minus 5 is negative 5. Now, there's one other step. What do I do with this radical? What do I do with the square root symbol? Well, the other thing that we talked about earlier this week is what the square root means is really that there's a 2 root. There's a 2 out here. What we're saying is this is the second root. This is the second root of x. Okay? For example, we don't see it and we usually don't write it down, but when we just have this, that means that there's a 2 out here. Okay? Sometimes we'll see examples where there's a 3 or a 4 or a 5. Come on, puppers. Come on. Come on, puppers. Mitts, come on. Sorry, guys, my puppies are barking to come in the room, so I had to let them in. Sometimes you'll see something like this. That means the cube root of x. Other times you might see something like this, and that means the fourth root of x, and so forth and so forth. So what we're talking about here in our example is the second root, or the square root. Now, in order to get rid of this square root, what we need to do is raise everything inside these parentheses to the second power. And whatever we do to the left side of the equal sign, we have to do to the right side. Okay? We're allowed to basically kind of do any math operation we like, as long as we do it to both sides of the equation. So what happens is this square and this square cancel out, eliminating the square root symbol or the radical, and all we have left is what's inside, which is x. Then on this side, we have negative 5 squared, which is, we know that negative 5 squared is equal to negative 5 times negative 5, so that's going to be 25. Okay. So there's a few different steps. I'm going to go through several example problems, walking you through the steps so you can learn them, and then at the end we'll summarize them all together. Okay, so let's take a look at this next example over here. So right here, what do we want to do? We want to isolate the radical, which means get it on one side of the equal sign and all the other numbers on the other side of the equal sign. So we have it isolated already. Now, the next step we need to do is get rid of the radical symbol. Get rid of the square root. So remember, we're going to take, oops, let me erase that. We're going to take everything and raise it to the power of 2. We're going to do the same to the other side. When we do that, we cancel out this radical. What's left is everything that was inside. So I'm going to bring down my x plus 5. And that's going to equal 0 squared, which is 0. Now I just need to solve for x by moving. I solve for x by taking all of these guys to the other side of the equal sign, or the other side of the equation. The way I do that is I subtract 5 from both sides. These 5s cancel out, and I bring down my x, bring down my equal sign, and I bring down this, which 0 minus 5 is negative 5. Okay? So if you have any questions or you didn't quite get it, go ahead and pause the video or rewind it and review it again. I am going to go over some example problems on the next page. We're going to go through quite a bit so you guys can see so you guys can get used to it, or you guys can see the steps. Okay, these are a little bit more complicated. Let's take a look. We're going to start with isolating. What is this? We're going to start by isolating the square root or the radical, which means I need to take this negative 3 and bring it to the other side of the equation. So I'm going to add 3 to both sides. These 3's will cancel. I'll bring down my square root of x, bring down my equal sign, and now I've got 2 plus 3, which is 5. Raise all of this to the second power. Do the same to both sides. Raise to the second power. Those cancel. Bring down my x. 5 times 5 is 25. Okay. Let's take a look over here. Got to bring this 5 to the other side of the equation in order to isolate my square root symbol. So remember, before we can do anything with the square root or the radical, we have to bring all the other numbers that are hanging out outside to the other side. How do I get rid of this? Okay. Let me see. Subtract 5 from both sides so that these two 5's cancel out. Bring down my square root of x, bring down my equal sign. 8 minus 5 is 3. Okay. Now that I'm just left with the square root of x, now I can go ahead and square this side, and then I square everything on the other side. The square root, the power of 2 and the square root cancel each other out. So now I'm left with what's on the inside. So I bring down my x, and then 3 squared is 3 times 3, which is 9. Okay, let's take a look at number 3 and number 4. Those look a little bit different. Go downstairs, please. In examples 1 and 2, we had a number, we were adding or subtracting a number on the outside of the square root. In 3 and 4, we have a number that we're adding or subtracting inside the square root. So we're going to follow the same steps. We need to isolate the variable, isolate the radical, which we have. We don't have to move anything to the other side of the equals yet. So what we're going to do is we're going to take this whole thing and raise it to the power of 2. And remember, whatever we do to one side of the equals, we must do to the other. Raise that to the power of 2. These cancel, and I'm left with x plus 4 equals 6 squared, which is 36. Okay, not quite done yet, because now I've got x, and I've got this 4. So what I need to do to solve for x is I need to bring this 4 to the other side of the equation. I can accomplish that by subtracting 4 from both sides. These two 4s will cancel out. I bring down my x, bring down my equal sign, and then I've got 36 minus 4, which is, let me see, 32. Okay, same steps, same process. Let's take a look at this one. So remember, I'm going to raise all of this to the power of 2, and I have to do the same to both sides. That will cancel out the square root. It will cancel out the radical and this power of 2. And what I have left is what was on the inside of the radical. X minus 7 equals 8 squared, which is 64. Now I've got to bring this negative 7 to the other side of the equal so I can have my x by itself. I accomplish that by adding 7 to both sides. These 7s cancel. I bring down my x, I bring down my equal, and then I've got 64 plus 7, which is 71. All right, let's look at 5 and 6. Okay, now we're adding a little bit of more complication to it. Not only do we have a number that we're adding on the outside, but we've also got a number that we have on the inside. So this is the thing we're going to do here, is that we need to do the outside first. So we need to bring this 2 to the other side of equal, and then we can get rid of that radical. So let's start with the first step. I can move that 2 by subtracting 2 from both sides. Those 2's cancel, and I'm left with x plus 5 equals 0 minus 2, which is negative 2. Now I can raise all of this to the second power, just like we did in problems 3 and 4. Do the same to the other side of the equation. The radical will cancel with the power of 2, and I bring down my x plus 5, and then I've got negative 2 times negative 2, which is going to be 4. Okay, not quite done yet. Now I've got that last step I got to do, which is bring this 5 over to the other side. So I can subtract 5, subtract 5. These 5's on this side cancel each other out. Bring down my x, bring down my equal, and I've got 4 minus 5, which is negative 1. Okay. I hope that you guys are starting to see kind of the pattern or the order of operations that we go in to solve for x. Okay, what are we doing here? Before we do anything with this, we have to take this positive 2 and bring it to the other side of the equation. So I can subtract 2 from both sides. Those 2's cancel each other out. Bring down what's left, which is my square root of x plus 5. 5 minus 2 is 3. Okay. Now I'm ready to cancel this out. Cancel this out by raising both sides to the power of 2. That cancels with that, and I'm left with x plus 5 equals 3 squared, which is 3 times 3, which is 9. I got to bring this 5 over to the other side. So we can subtract 5 from both sides. Then I bring down my x, bring down my equal sign, and I've got 9 minus 5, which is 4. Okay, and that's it. I'm going to go through a few more example problems. I'd like you to try to pause the video and see if you can figure these out on your own before I show you the solutions. These are very similar to what's going to be in the Delta Math, so I want you to pay attention to these next problems. Let's do one more. Let's do 7 because it's very similar to 5 and 6. Okay. I want to get rid of this first, and then I'll work on the radical. So I'm going to add 20 to both sides. Let me try another color here. These 20s cancel each other out. Negative 20 plus 20 is positive 8. Now I can square or raise both sides to the power of 2. These cancel each other out. And I'm left with x minus 8 equals 8 times 8, which is 64. Add 8 to both sides, so these two 8s cancel out. I bring down my x, bring down my equal, and I've got 64 plus 8, which is 72. Okay. If you want additional practice, you can work on number 8 on your own. Okay. Let's take a look at 9 and 10. These look a little bit more challenging. How come? Okay, these are a little bit harder. This is what you're going to see in the Delta Math. We've got a 5 times x here. And the other problems, we only had x. We weren't doing any multiplication inside. So we're going to have to figure out how to solve, how to do that part. We've still got this number on the outside that we've got to take to the other side of the equation. And then we still got to figure out what to do with this whole radical. Okay, so there's going to be an extra step in solving these kinds of problems. Let's do what we need to do first. We got to bring this 1 to the other side. So I'm going to subtract 1. Let me erase this from both sides so that this 1 and this 1 cancel each other out. Bring down my 5x plus 14. Bring down my equal sign. I've got 4 minus 1, which is 3. Now I'm ready to cancel out my... I want to bring this down. Let me make a little bit more space so I'm not crowding everything. Bring down my equals. 4 minus 1 was 3. Now I'm ready. Remember, there's always a 2 right there. Now I'm ready to raise this to the power of 2. These cancel each other out. I bring down what's left. 3 squared is 3 times 3, which is 9. Okay. Now I've got 2 steps to get to where I have x by itself. First step, bring that 14 over to the other side. Those cancel. I'm left with 5x equals 9 minus 14, which is negative 3. Oh, it's negative 5. Okay, so check it out. I'm not quite done because I've got this 5 that's in front of the x. I need to get rid of it. This is saying 5 times x, so I have to do the opposite operation in order to bring it to the other side of the equation. So this 5 and this 5 cancel out. And what I'm left with is x equals negative 5 over 5, which is the same thing as negative 1. Let me show you another example. Yeah, let me show you this one. I'll go a little bit slower for you guys. Okay, so remember, before we do anything with the radical, we have to bring all the other numbers to the other side of the equation. So let's start with that. I can subtract 7 from both sides. These two 7s will cancel each other out. And I'm going to be left with 8x plus 28. Bring down my equal sign, and then 13 minus 7 is, what's 13 minus 7? 6. Yeah, so it's going to be 6. Now I'm ready to cancel out the radical by raising both sides to the power of 2. These will cancel each other out, and I'm left with 8x plus 28. Bring down my equals, and then 6 squared, which is 6 times 6 is 36. So I've got 2 more steps here. First, remember, when we're trying to isolate the variables or solve for x, we go in the opposite order of operations. So you do the addition and subtraction first, which means I've got to get rid of this. I've got to take this 28 to the other side of the equation first, and then I'm going to work on this multiplication of 8 times x. So let's see. First, I'm going to subtract 28 from both sides. Those will cancel each other out. What's left is 8x. Bring down my equal sign. 36 minus 28 is going to be 8. Does that make sense? 36 minus 28, it's 8. Now I can get this 8 to the other side by dividing both sides by 8. These will cancel each other out, and I will have x equals 1. Let's take a look at 11 and 12, and then 13, 14, and the rest we'll cover on Monday. Okay. So now this one's a little bit different because check it out. Now we have an x on this side, we've got an x on this side, and we've still got our square root or our radical that we need to figure out. So this is going to be a little bit different. I think you understand the steps by now, so let's see what we can do. Actually, no, you know what? These are the ones that are more complicated. In order to solve these, we'll need to use what we've already learned previously in the class, and we'll have to remember a few things from Algebra 1 in 8th grade. So 11 and 12, let's go ahead and stop here. 11 and 12 and 13, 14, 15, we will go over in class on Monday. Just make sure you understand these. If you don't, let me know in class on Monday so we can do it. Let me go over number 10 one more time so that we can make sure we really understand these that are a little bit harder, because this number 10 and number 9, there's going to be problems like this in the Delta Math. Okay. So I'm going to do this one more time for everybody to see. Okay, so remember, first step, get this 7 to the other side of the equation. Then we'll focus on simplifying this. The way I can accomplish that is by subtract 7 from both sides. Those 7s cancel each other out. Bring down my equal sign. Bring this down. 13 minus 7 is, we said that was 6. Okay, now on this side, now I can raise both sides to the power of 2. What I'm going to have is 8x plus 28. And over here, I'm going to have 36. I need to bring this 28 to the other side so that I can start. My goal here is I'm trying to isolate x or get x by itself. So I do the 28 first, then I'll come back for the 8. Subtract 28 from both sides. Those cancel each other out. 36 minus 28 is 8. I bring down my 8x from over here. Now I can figure out how to get rid of this 8. Remember, this is 8 times x. So in order to get this 8 to the other side of the equation so that I have x by itself, I'm going to divide both sides by 8. So that these 8s now cancel each other out. I bring down my x, and 8 divided by 8 is 1. Okay, I hope that helps. I'll see you guys Monday. I hope you all have a good weekend. Please remember to work on the IXL, the Delta Math that's due today. This Delta Math will close on Monday in the afternoon, so you'll have a little bit of time on Monday to work on it. So if you have questions, you can ask me in class. Okay, we'll see you all. Thank you.